I'd like to discuss inverse functions with you. An inverse function is a function that maps its output values onto its input values. In other words, we're going to invert our x's and our y's, which means we're going to switch our x's and our y's. To signify that a function has been inversed, we are going to use this notation: f raised to the negative 1 of x. It is f to the negative 1 of x. The negative 1 power is on the f function, not on the x. So let's first graph the regular function, x minus 3 divided by 2. So let's pick some negative numbers, 0 and a positive number. So if I would pick a negative 3, negative 3 minus 3 is negative 6 divided by 2 is negative 3. So negative 3, negative 3. If I pick 0, 0 minus 3 is negative 3 divided by 2 is negative 3 halves, or negative 1.5. So 0, negative 1.5. If I pick negative 1, negative 1 minus 3 is negative 4 divided by 2 is negative 2. Negative 1, negative 2. If I pick positive 3, 3 minus 3 is 0, divided by 2 is 0. 3, 0. If I pick 1, 1 minus 3 is negative 2, divided by 2 is negative 1. 1, negative 1. And I would have this line as my function. So this is my f of x, my function. Now if I'm going to do the inverse, it simply means I have to switch my x's and y's. So this was negative 3 for x, negative 3 for y. So when I switch those, I still get negative 3, negative 3. I'm going to do this one in green. 0, negative 3 halves would be negative 3 halves, 0. So negative 1 1/2, 0. Negative 1, negative 2 would become negative 2, negative 1. Three, 0 would become 0, 3. 1, negative 1 would be negative 1, 1. And I get this line as my inverse function. So you should be able to tell that if you were to fold these functions so that one lied on top of the other, they would fold over this line, y equals x, which explains why when you graph the inverse you get the exact same function, because you switched your x's and your y's. So what does this mean? When you have a graph, when you will pick points on the original function, and then you will switch your x and y coordinates to get the inverse. if we were going to write the inverse of this function as an equation, we would switch our x and our y. So this presently reads y equals x minus 3 divided by 2. So it would read x equals y minus 3 divided by 2. And then we're going to solve for y. So first I would have to multiply by 2. And then add 3. So I would get y equals 2x plus 3. And that is my inverse. So when you write the equation, switch x and y, and solve for y to get the inverse. All right, let's try this. What we're supposed to do is f of g of x and then g of f of x. So if I do number 2, if I do f of g of x, I see that g of x is inside. So I take the g of x function and put it into the x of the f function. So it would read x minus 5 plus 5, which is x. Where if I did g of f of x, I'm taking the f function and putting it in the g. So in this case, I'm taking this and putting it in there, which would read x plus 5 minus 5, which also gives me x. Let's see, x is e. Okay, let's try number 3. F of g of x would be 3. In the place of x, I put my g function, x divided by 3. And that gives me x. If I do my g of f of x, I'm going to take my f function and put it in the x spot. So in place of x, I would write 3x divided by 3. And that also gives me x. Okay, let's do number 4. F of g of x. So it reads 5. In place of x, I put my g function, 1/5 x minus 4 plus 20. 1/5 of 5 is 1x. 5 times negative 4 is negative 20. Then plus 20. And that gives me my x. G of f of x. It is 1/5, and in place of x, I put my 5x plus 20, and then I have my minus 4. 1/5 of 5x is x, 1/5 of 20 is 4, and that also gives me x. Let's do number 5. F of g of x. In place of x, I put x cube root of x minus 5, and then add 5. Well, cube root of the cube, that undoes itself, so I have x minus 5 plus 5, which gives me x. Then g of f of x, I put my cube root. In place of x, I put x cubed plus 5, and still under the cube root is minus 5. 5 minus 5 is 0, so this is the cube root of x cubed, which is x. And when you're doing these, you're going to have to show all your work like this. And the last one, number 6, f of g of x. In place of x, I put the fifth root of 10x plus 8. And that is to the fifth power minus 8 all over 10. Which means the fifth roots undo each other. So I have the square root, or excuse me, the roots would undo each other. So it would be 10x plus 8 minus 8 over 10. That is 10x over 10. That is x. And the other way, g of f of x, the fifth root of 10 in place of x, I put x to the fifth minus 8 over 10, and then I still have plus 8. So those undo each other, and I get the fifth root of x to the fifth minus 8 plus 8 is the fifth root of x to the fifth, which is x. So we can see, to verify that something is an inverse, we will do f of g of x, and we will do g of f of x, and we should get x. Then we have an inverse. So let's just write that down. To verify an inverse, find f of g of x, and it should be the same as g of f of x, which means they both should equal x. You must do both ways and get a value of x from it for it to be an inverse of each other. So this says verify that negative 3x plus 6 has an inverse of negative 1/3 x plus 2. So first I do f of g of x, and I'm calling my inverse my g of x. So I take that function and place it into the x. So it'll read negative 3 times, in place of x, I write 1/3 x plus 2, and then I have plus 6. Negative negative is a positive. A third of 3 is 1x. Negative 3 times 2 is negative 6. Then I have my plus 6, which gives me x. So far, it looks like I have an inverse, but I must do it the other way as well. And that is g of f of x. So this time I take negative 3x plus 6 and put it in the x spot. So that is negative 1/3, and instead of x, negative 3x plus 6. And then plus 2. Negative negative makes a positive. A third of 3 is x. Negative 1/3 times 6 is a negative 2 plus 2, which gives me x. So in this case, I got x when I did f of g of x and when I did g of f of x. So these are inverses. Now it says to find the inverse. If you're finding the inverse of an equation, again, to find an inverse means to switch x and y. So I'm going to switch this x and this y. So then it would read x equals negative 3y plus 6. Then I solve for y. So I would subtract my 6 So I have x minus 6 equals negative 3y. Still solving for y. So I would divide by negative 3. So I get y equals negative x over 3 plus 2. That would be my inverse. So to show you have an inverse, you must always put this f of negative 1 of x onto the function. If you leave that out, you have not completely shown that you have an inverse, and you will not get full credit. Okay, for the next one it says find the inverse of x to the fourth. So this is y, so I switch my x and my y. So I get x equals y to the fourth. So to solve for y, I would fourth root both sides. So this gives me y equals the fourth root of x. That should be my inverse. But it asks me, is this inverse a function? Well, when I put a fourth root on, I get plus or minus. So I would not get a function. Because graphically, that would be this graph. And this is not a function. So to test if a given graph is a function, so if I'm testing if this is a function, y equals x to the fourth would be this graph. So if I'm testing if the inverse is a function, I would do the horizontal line test. And it does not cross at just one place. It crosses at 2. So it is not a function. So how about the inverse of a cube root? Well, this is my y and this is my x. So x equals 4/3 pi times y cubed. I multiply both sides by 3 over 4 pi. So I get 3 over 4 pi x equals y cubed. Then I would cube root both sides. So I get f inverse should be the cube root of 3 over 4 pi x. And yes, that is a function. Because a cube root is like this. If I do the horizontal line test on it, it touches at just one spot. So it is a function. So to test if an inverse is a function, do the horizontal line test. And that horizontal line should cross at one point. To be a function.